All right, so lesson 3a. In a previous section, we talked about coterminal angles. Coterminal, what does that mean in your head now when you see that vocabulary word? What makes an angle coterminal? It ends at the same spot as another angle. So for example, if we talk about 10 degrees, which is a non-unit circle value, it could be coterminal with negative 350, turning from 0 from the standard position, negative 350 degrees, or it could be coterminal with full revolution, 360 plus 10, which is 370. So we can talk about positives and we can talk about negatives. So if I talk about an angle of 570 degrees, give me one angle within the unit circle for which it is coterminal, which means your degrees have to fall between 0 and 360, or between 0 and 2 pi. Okay? And usually when we write this, we will choose 0 over the 360 or 2 pi definition, so that's why I'm going to use parentheses. So what do you think? 570, where does it end? That's the same as a unit circle degree value. I gave you degrees, you give me degrees. 210, how'd you get it? Subtract 360. So I've taken a very large number, reduced it back until it was within this interval. Got it? What about 21 pi over 4? This is a good place for you to check in because now we're going to go to radians, which most of you don't enjoy yet. 21 pi over 4. Is it bigger or smaller than a unit circle value? Way bigger, correct? So our procedure was to add and subtract 360, so we're going to add and subtract what? 2 pi. So if I subtract 2 pi, what do I get? Take one revolution away. This is the mental math. 21 minus 8 is 13 pi over 4. Minus another 2 pi gives me what? 5 pi over 4. Is 5 pi over 4 in the unit circle? Yes, it is. Does anyone have a question about how to do those calculations? Yes, ma'am. I did say subtract 8. What's the denominator? 4. So 8 pi over 4 is the same thing as 2 pi. You need a common denominator to add and subtract. Okay? All right, 17 pi over 6. Much bigger than the unit circle. Subtract 2 pi, what do I get? 5 pi over 6. Does anybody have a question why the answer is 5 pi over 6? Now's your time to ask. Mental math, simple fractions, we're good? Thumbs up? Thumbs up, we're all good? Nobody's bad. No questions. All right, now the next one is tricky. Negative 23 pi over 3. Okay, so I'm going to write that one here. Negative 23 pi over 3. That means I'm going in the downward direction. So I'm still going to add. I'm not going to subtract. I'm going to add 2 pi. What does that give me? Add 2 pi. Negative 17 pi over 6. Add another 2 pi. Pi over 3, sorry. Negative 11 pi over 3. Still not there yet. Add another 2 pi. Negative what? Negative 5 pi over 3. We're getting close, but we're still in the negatives. So I'm going to add another 2 pi. What do I get? 1 pi over 3. That would be between 0 and 2 pi, so that would be the answer, pi over 3. All right, last chance. Any questions on doing the mental math to get there? How did I? Why did I? Okay, so coterminal angles. When you see coterminal, think add and subtract 360, add and subtract 2 pi. Go. Then you would do 18. Add and subtract 18 pi over 9. Okay, so all right, so let's make an example 5. Example 5. If I I told you, hold on a second, 21, not 21, 22 pi over 9. That's bigger than 2 pi, right? Because 18 is 2 pi, so I would subtract 2 pi. Same procedure. But now I'm going to subtract 18 over 9 because that's the same thing as 2 pi. So that would give me, if I subtract 18 pi over 9, that gives me 4 pi over 9. And 4 pi over 9 would be in quadrant 1. Because 4 1/2 would be halfway. So that would be an answer. That would be the solution between 0 and 2 pi. It's not a unit circle value, but it's the same procedure. Everybody with me with this one? Mental math wise? You're checked in, you're good? Okay. That's good. All right, so now let's erase all of this. All right, this is the most important part of today's lesson, and I don't know why we get to the test and it's like, Mrs. Gomez, you're asking me for a reference angle. What's a reference angle? We've been doing these since day 1. So don't just draw what I have up here because I'm going to add a little bit to it. A reference angle is when you have an angle in the standard position, which means its initial side is the positive x-axis. And we want to find the acute angle, which is going to be known as theta prime. Not like Optimus Prime, theta prime, formed by the terminal side of the angle on the x-axis. Okay? So here's my example. I'm going to use a numeric example, and I'll switch to radians and do a little bit for each of them. So for the first one, let's say that the first example up here is 420 degrees. Do you agree that 420 would end about here? Yes? Okay, so 420 is a full revolution all the way around up to this point. That's going to be theta. Oh, this marker's fantastic. That's terrible. So this is going to be my theta value, okay? My theta prime is going to be 60 degrees. That's my reference angle. Theta prime will always be acute. It will be less than 90 degrees. Quadrant 2. So for example, in quadrant 2, let's say that my theta in this example is negative 225. So negative 225 finishes here. My reference angle, theta prime, is going to be 45 degrees. Notice here's that triangle that I would lay down if I had a cutout. It would be there. All right, so before I do the next two, what questions do you have? Anything? Does it make sense? What you should be looking for to answer the question about reference angle being theta prime. All right, so quadrant 3. Let's say quadrant 3 was theta is equal to negative, let's see, 140, negative 140 degrees. What would theta prime be? 40 degrees. Theta prime is always found by taking your angles to the next closest x-axis, never the y-axis, always the x. And then we could do quadrant 4. Quadrant 4 could be like theta is equal to 310 degrees. What's theta prime going to be? $50 degrees. Yes? Makes sense? It's a visual operation. Basically, you're going to want to take whatever theta is, you want to find its location, and then you want to think about the size of theta prime. It will always be between 0 and 90, or a radian value. Good? Can I erase? No questions. Last chance. moving on then. The directions will say find the reference angle. 315 degrees falls in which quadrant? 315? Quadrant 4. It's going to be right here. Okay, so find the location of the angle. Then we're going to draw the reference triangle in. What's the size of theta prime? 45. 7 pi over 6, another one. 7 pi over 6 is going to be over here. It's the short triangle, if you will, visually on the unit circle. Okay, now this one I'm going to put a star by. Notice I gave you radians, so I'm going to want theta prime in radians. Okay, what's the size of theta prime in radians? Pi over what? Think of the arcs. I've got 7 pi over 6, yes. 1 pi over 6. So, big idea here is that if I give you radians, your answers are probably going to be pi over 3, pi over 4, or pi over 6. They're the only 3 choices. All right, let's move on to this. We just went over 2 vocabulary words. We did coterminal angles, coterminal, and we did reference angles. They may or may not be the same thing depending on how many revolutions you travel on the unit circle. So let's take a look at 17 pi over 6. Right, so I want to do 2 things. First thing, let's find 17 pi over 6. Okay, please draw a little circle. You have this example in your notes, yes? Do you have this one or no? No, okay, so make a little box on the far right. I want you to add this to your notes. This is a really good example to illustrate the difference between these concepts. Okay, make a circle, and I want you to put a dot where 17 pi over 6 is. I want to come around and see if you can do that on your own yet. Can you count the arcs or convert to degrees or do something that tells you where 17 pi over 6 is? There's no rush. We're all different places right now. All right, good. Did you do all this before? Did you do all this before? Okay, so for those of you that find this difficult to count because of all the different locations, here's what I would suggest you do. Take the denominator, double it, and say, okay, 12 pi over 6 plus 5 pi over 6. Where is 5 pi over 6, which is what you were asked to memorize? Right here. Okay, so 17 pi over 6 is located there. 17 pi over 6 is more than 1 revolution. So if I don't go a full revolution and I come in, what's the size of this angle? How big is that swoop? Just that swoop. If I don't do the full revolution. Which is in what in radians? 5 pi over 6. So the coterminal angle would be 5 pi over 6. That would be a coterminal. But now the reference angle is going to be the size of this theta prime in radians. What's the size of that angle in radians? Pi over 6. Do you see the difference in the question that I'm asking you to find those two things? Yes.
So you just take away the 5 to find the prime number. Like the 5 pi over 6, you just take away the 5.
Well, yeah, wait. As long as you have a coterminal angle that's reduced. Here's what I mean by that. This is why I say that. So let's say I had 8 pi over 6. 8 pi over 6 would not have a pi over 6 as its value, because you would have to reduce everything. Then you would have 4 pi over 3, which then you could say it's pi over 3. You know what I'm saying? That's the exception. If you have a reduced coterminal angle that's on the unit circle, you can just drop the coefficient, yes, the numerator coefficient. Yeah.
I'm just confused about like say if beta prime was kind of in a different spot in the quadrant, we still have to change? Would we have to change like how close it is?
All right, I'm going to ask this class at large. Can somebody give me a translation of what he's asking? I don't understand, and it's only probably because of the vocabulary that I use and what you're saying. We're just not.
Like, you know how it's closer to -1 to 0?
Yeah.
Would that be different if the reference angle was closer to
Okay, let me see if I'm on the right. So, like, if this was here instead, is that what you're asking me?
like closer to the
y-axis?
So here.
yeah, would that change?
Okay, well, if that was the angle in question, wouldn't that, first of all, either coterminal or actual angle be 2 pi over 3? Like, this is actually located at 2 pi over 3. So that would make the reference angle pi over 3? Yes? All right, that's what I thought you were going with. Okay, so you got it now, what we're doing? Yeah, because remember, we would have taken those triangles when we did it and, like, flipped it around and put the 60-degree angle in here. We were talking about degrees. All right, any other questions to clarify? Reference angle versus coterminal. Coterminal, add and subtract revolutions of 360 or 2 pi. Reference angles are basically always acute. It's that small little triangle central angle. All right, moving on. Moving on. All right, so now, this is where the road meets the rubber. We're going to take what we did yesterday, and we're going to merge it with the unit circle. You're going to be asked to find the following functions. The sine of 315 degrees. Oh my gosh, is she insane? No. First of all, when it says 315 degrees, I want to know the sine, actually, of theta prime. Okay? So we're always going to find acute angles. When we did the assignment yesterday, we were always labeling theta as an acute angle. So the way we do that is we go to 315. 315 is going to be right here. Theta prime is 45 degrees. 315, what do I have for my x and y values? Okay, so I have this. I have root 2 over 2, negative root 2 over 2. Okay? So now I'm going to take those, and I'm going to put them into my triangle. So I'm going to say this is root 2 over 2, this is negative root 2 over 2, and this is 1. And I'm going to say, okay, 45 is my theta prime, so that's in the middle. I don't even care that it's 45. I know that this is theta prime. If I want sine is what ratio? What over what? O over h. So the opposite side is negative root 2 over 2. The hypotenuse is 1. So when I set up this superfraction, fraction within a fraction, I reduce it and I get negative root 2 over 2 is my answer. That is the sine at 315 degrees. Here's your opportunity. What part in the process do you need me to repeat? Sine of 315, I'm going to look for theta prime. I'm going to find 315. I'm going to draw the right triangle that exists and label the sides based on my ordered pairs. What does that mean? Everything I give you has to be unit circle values. I then put those as sides, hold on one second, and then I use my ratio and simplify. Go ahead.
How do you reduce that superfraction if it wasn't?
Let's do one. Let's do one, number 2. We're going to get to that. I just wanted to give you a simple one to start with. So next one is pi over 6. Okay? Pi over 6 is in quadrant 1. Pi over 6 is right here. Set up my superfraction. I know that this has a height of 1/2. This is root 3 over 2. This is 1, right? Big triangle side is root 3 over 2. Little tiny bit is 1/2. What's cosecant? What over what? Cosecant goes back to sine. So it's going to be h over o. Okay, so my hypotenuse is 1 divided by my opposite side, which is 1/2. What's the rule when I have a numerator divided by a fraction? Prerequisite? Take 1 times what? What do I do with the 1/2? Reciprocal it. 2 over 1, whatever that is. That just gives me 2 as my answer. So second review skill is fraction within a fraction when I have a denominator that's a fraction. All right, 4 pi over 3, same procedure. 4 pi over 3 is going to be down here, this tall triangle. This is going to be negative 1/2, negative root 3 over 2, and 1. Here's my theta prime. Cosine is what? A over h. The adjacent side is negative 1/2. The hypotenuse is 1, which is negative 1/2. Now we're going to get to your question, right on this next one. Is there anything that I've done so far that, I know I went a little fast, but you're looking at it saying, I don't know where that number came from. How did you generate that? Go ahead.
Where'd you get the size of the triangle?
All right, did you take the unit circle quiz? Okay, so 4 pi over 3 is in quadrant 3. It's the tall triangle. The x value was negative 1/2. The y value was negative root 3 over 2. Correct?
Yes.
So when you plot those, that tells you that you went over negative 1/2 x, and you went down y, x and y. All right, also, that does bring a very good point to light. Do you know what's weird about this triangle in number 3? Do you see how I'm labeling the sides with negatives? The quadrants matter. So we never really dealt with triangle sides that had lengths that were negative, but now we will talk about that because we're using a distance in the coordinate plane specifically related to the circles. So this is a negative 1/2 because I went to the left. This is down negative 3 over 2, root 3 over 2. All right, I'm going to erase all this so I can do the math nice and big for the next one. Last example, tangent of 135. 135 is which quadrant? 2. So here's kind of my blow up of quadrant 2. Maybe right here. Here's my triangle. Here's my theta prime. This is negative root 2 over 2. This is positive root 2 over 2. This is 1. Hypotenuse is always 1. What's tangent a ratio of? O over A. Okay, so my opposite side is going to be, I'm going to set up a fraction here, so I want O over A. My opposite side is root 2 over 2. My adjacent side is negative root 2 over 2. Notice fraction divided by fraction superfraction. What is the rule for reducing that? Take the numerator times what? What do I multiply the numerator by? 2, don't forget the negative, over root 2, correct? This is a negative, so this has to be a negative. Okay, now I'm multiplying, so what's the great thing I get to do? cancel, cancel, leaves me with what answer? Negative 1. Anytime everything cancels in a fraction, the answer is 1. Think about it. 7 divided by 7 is not 0, it's 1. Now, there is a shortcut, which I'm going to remind you of right here, and it is this. Root 2 over 2 divided by negative root 2 over 2. What do we do when anything is the same? You can cancel them. So I could have actually done that right from here and just gotten negative 1 also. But I wanted to review the reciprocal rule because there will be times when you can't cancel like that. You're going to have to multiply by the reciprocal and cancel. So it's a good time to do that. Questions? All right, example 2. What happens when you can't draw a reference triangle? So do you have a worksheet in your homeworks? You do, correct? Take a look at number 5. This is part of your homework tonight is a worksheet. So these are in the notes. I wanted to talk about it. We want to talk about the secant of pi over 2. All right, those of you who have not been paying attention, where you've seen this before or whatever world you're living in right now, please come back to this world because this is a very abstract idea. Do you have a worksheet in there? Good. The very next page, number 5. Oh, you don't have that problem? Well, it doesn't matter. We'll do this one. This is the worksheet that you have in tonight's assignment. It's on there, the next page. Is it on the page before? Where is what's wrong with this packet? What's wrong with this packet? Here. Is everybody's packet like that? Like, completely out of order?
Yeah. Oh, those look kind of out of order. I flipped some.
Oh, you flipped all these.
Well, not all.
Oh, so yeah, that's how it should go. It should go worksheet, worksheet page, etc. Yes.
I've got blank page.
Okay, go to the next one. That's the first of the worksheet. Move it over. All right. So what is number 5? You don't have secant. You have cosine, right? Cosine of pi over 2. All right. So let me. All right, well, I'll just do this one as cosine. Hold on. 1, 2, 3, cosine. No, you have number 5 as cosine of pi over 2. I changed mine. What? Okay, so 90 degrees is the same thing as pi over 2, right? Yeah. Same thing, cosine pi over 2. All right, so now that the confusion, we are on a worksheet. It has 8 problems on one side and a whole bunch on the next. Follow through with the packet there. At cosine of pi over 2, if we follow the same instructions, we draw a location, which is here. Okay, here. Right. Now, what I want to do is, theory-wise, I'm going to just draw something else here. I'm going to go, think about blowing up and going 1 degree off of center. If I go 1 degree off of center and I draw in my triangle, do you notice how x is extremely tiny? X gets smaller and smaller and smaller as I get closer. It's like real big here, and as I move up to this point, it's getting smaller and smaller and smaller. Yes? Can you conceptually understand that x is approaching 0? Okay? At pi over 2, my x triangle would be 0. What would my height be then? What's this approaching? 1. And I told you the hypotenuse is 1. So what I just drew in this triangle up above, 0 for x, 1 for the height, 1 for the hypotenuse, that's a theory triangle to understand this. Where would my theta prime be? It's still in the middle here. Okay? So the reason I want to use the reference triangle to look like that is if I want cosine, cosine is a over h. So what's the adjacent side to this orange dot? 0 over the hypotenuse, which is 1. What is 0 divided by 1? 0. Okay. By the same token, if I had, this is not on there, but let's say I had another example that was the secant of 90 degrees. Using this same little triangle, x went to 0, secant goes back to cosine, so now I'm looking for h over a. The hypotenuse would be 1, the adjacent side would be 0. My answer would be no solution. Because again, I cannot divide by 0.